our third year, I think. What time is it?
6:39.
Okay, yeah. Got plenty.
You're the third one to arrive. They don't count. They're setting it up. Now, we're not setting. 6:39. You're the third one to arrive. They don't count. They're setting it up. No, we're not setting. 6:39. You're the third one to arrive. They don't count. They're setting it up. We're not
my biggest thing with your dress is I want you to be in love. With some of the people.
It's not in chill mode. The options. Yeah. Just these from us. Actually. It's a clock. You see it, so. Schedule.
How long till you graduate?
June, and I'm not even really taking classes right now. It's I have
For getting a graduate degree? Hello, hello. Go further down with that. I better go lower with it. There. Okay, I'm rigged. Ready? Testing 1, 2, 3. Can I be audible? Hello, hello, hello. So they're both good. I'll probably speak a little bit louder because I'm used to classroom stuff.
geological sciences department. I know Randy, both of those for later, and tonight. And it's great to have you at the Quey Hebrew lecture. And Quey Hebrew sounds, it's a different name, and that is
When
a
you
fellow's
are
name. I don't
ready,
know if you're
just
aware
make
of
sure
that.
to turn.
His name, what's his middle name? Quey Chester Hebrew Agency here. And he's a non-star department, and he got into geology working in Oman when he was young, and then went on to work after he got his degrees. He went on to work for major petroleum companies, exploration, and he set up an endowment to fund this lecture series, which is going on for, I don't know, 30 years now, I think, at least, right? At least 30 years. So we really appreciate him and his family. He's passed on, and so has his wife. But we love when the alumni support our students by having such lectures as this tonight. And so we're going to start off with a prayer, and let's see, who's going to say the prayer?
Seth.
Oh, there we go. Okay, come on out, Seth.
Dear Heavenly Father, we're very thankful to have this opportunity to meet together, to learn from each other and listen to Dr. Creamer's lecture today. And please bless us that as we do listen, that we can learn and that we can connect the information here to our own studies on geology, that we can continue to find the best way to both provide the things that the world needs, but also find a way to do it in harmony with your. Say that in the name of Jesus Christ, amen.
Thanks, appreciate that. So, want to say again, thanks for coming out tonight to catch Dr. Kramer's lecture. And Greg, you're going to do the introduction.
Yeah. Okay, yeah, thank you all for being here. So I'll introduce Dr. Dave Kramer. So I just want to read a few things that is pretty impressive here. But yeah, Dave's research includes work on water and international security, maintaining good water quality supply for people and ecosystems, especially in economically developing regions. So I think that's super important to have people working on that. Environmental contamination, like I'll talk about tonight, and then water quantity and quality. So a broad range of hydrogeologic topics, but also socio-economic type problems. He has been invited and lecture, keynote speaker at many conferences, including testimony before the U.S. Congress, U.S. Nuclear Regulatory Commission, and has addressed the United Nations General Assembly. It's also given over 150 invited lectures, 151 tonight. Keynote addresses and presentations over 50 universities, and spoken all over the world. And also is the former president of International Association of Hydrogeologists up until about a year and a half ago. And then also I want to point out that he is the co-author on both of the textbooks we're using this semester for our groundwater class, the applied hydrogeology, and our contaminant hydrogeology class. So kind of fun to have somebody famous here for our students. And then I just want to point out that he's been running the Grand Canyon, Colorado River through the Grand Canyon as a oarsman since the early 80s, and kayaked it here in 83 when the river was at 100,000 CFS or so. So it'll never be that high again. And so 40 times he's been down the river, at least 10 times on a kayak. For me, that's like a once in a lifetime dream to do that. So, but please welcome Dr. Dave Kramer.
Thank you, Greg. Can I be heard in the back? We're good? Okay. Well, Greg, thank you for a really nice introduction. My father would have really liked to hear that. My mother would have believed it all. It's a pleasure to be with you today. I'm just delighted to be here. So I'm a professor emeritus at the University of Nevada, Las Vegas, and past president of the International Association of Hydrogeologists. All you hydros there, we have free membership for students if you're interested, and so you can see me afterwards. I'm just pleased to be here. I'll start off with my presentation outline for you, and That is actually me cartwheeling through Upset Rapid. And the reason I started off with this is this is not in 1983 that Greg mentioned, but it'll explain to you if I have a waterlogged brain in this lecture, you'll understand why, because of instances like this. So I first want to talk about the importance of springs in arid lands. The whole reason I'm giving this lecture is because I'm concerned that some of the mining might impact springs in the Grand Canyon that I've been studying for about 40 years. There's some political, economic, and historical background that I'd like to cover. And then the mine is in a geologic formation called a brecciapite. So I want to talk a little bit about brecciapite mining and what that's like. Following that, I'll talk about a little bit of ecological safety and mining arguments. I'll start off with why the mines think that their mining is safe, and then a lot of academics and experts don't agree with them, and I'll try and give you that argument. The mines say that the geologic structures in the Grand Canyon are layer cake. And if you visit the Grand Canyon, it does look like a layer cake, but there are problems with that interpretation. Talk a little bit about soil, not too much about soil, but maybe a little bit of air contamination from mining operations. And these are uranium mines. And then if there's time, I've got some videos of river running at the end that maybe might be fun to watch. So first I want to start off with an acknowledgements and wonderful graduate students through the years. Here we have Colin, Austin, Venus, and Luke in a snowstorm coming out of the Grand Canyon. A lot of these bushwhacks are to places far off the trails to get to the source of the springs. You want to take water right out of the springs themselves. But acknowledgements, first of all, I want to start off thanking you, and thank you for the invitation, Greg and Brooke, and I really appreciate being here, and to the sponsors of this lecture. You can see a picture of a fellow in the snow there. Sometimes the snow blows sideways, and your water bottles that you've taken a sample, that you filtered and acidified, you have to sleep with them in your sleeping bag so they don't freeze. And then in the middle of summer, you have to hike before the sun comes up, hide in the shade, and then when the sun goes down, start hiking again. So this is Jim Fitzgerald, who on one of our trips, we were the first ones to find high uranium in springs over drinking water standards. Kim Zukowski here working at night, and she's also on the far right over there sampling one of the springs. So graduate students, a couple of associations now, the Grand Canyon Conservancy, it's now called, has, you don't get a lot of money for working in national parks, but they did supply some. And then other coordinators, the Spring Stewardship Institute out of Flag and the Grand Canyon Trust. These are Park Service people who have helped us out through the years. A lot of grads and undergrads that I'd like to at least recognize. And then we also have boatmen, academics from other universities, Park Service personnel, and other people who have helped us out. And so it's adventurous work, working in the Grand Canyon. Although Greg mentioned the river running, most of the springs are closer to the rim, and so most of them are hikes and rappels and bushwhacks to get to. So why are springs important in arid lands? Well, there's a couple of reasons. And by the way, this picture is a place in the Grand Canyon called the Silver Grotto. How many people have been down the river in the Grand Canyon? A couple of you. So you probably know Shinuma 1 here. We call this the vortex run. If you run really, really fast, you can run around this pool without falling in, but you got to run fast. So one reason springs are important is to support recreational uses. And in the Grand Canyon, that's super important because many of the springs are like 10 miles apart. And in the middle of summer, you better be able to get to and depend on the next spring coming up. They're a long-term indicator of ecosystem health. And in the Grand Canyon, there are some species that can go spring to spring, but others that can't. There are some endangered species at some of the springs. Native Americans, too, have important cultural and religious values of the springs in the Grand Canyon. So those are some of the reasons. Teddy Roosevelt, when he talked about the Grand Canyon, said, you can't improve it. Don't try to improve it. You know, you don't need to build a hotel in the bottom of the Grand Canyon. My ethic was a little bit different. My Boy Scout Scoutmaster said, leave your campsite cleaner than you found it. And that's sort of like what I think we should do with the Grand Canyon. That's Deer Creek Waterfall, by the way. This is another waterfall in Havasu Canyon. Native Americans live there. It's the smallest tribe in Arizona with 30 families, but it's very pretty. There are also a lot of very vulnerable small springs in the Grand Canyon. I'm showing you some of the bigger ones because they're fun and pretty to look at. But there's a lot of issues with uranium mining and development in the Grand Canyon. So the National Park Service has concerns with contamination of springs and seeps, a migration of contamination off-site by trucks and things like that, dewatering of springs, and I'll talk more about that later, fractionation of wildlife corridors, view and soundscape, and traditional cultural properties. Over a dozen Native American tribes are around the Grand Canyon, and every one of them oppose mining. The trucks that haul uranium from the Grand Canyon to Blanding, Utah, have to go through the Navajo reservation, and they don't like it. So the issue here is balancing a national energy resource that we really need with protecting natural resources of the Grand Canyon. So this is most of the pictures here from the Supai village down in the Grand Canyon. And that's a circle dance, and it's actually a protest for uranium mining down in the Grand Canyon about a year and a half ago that I was able to participate or at least go down and be with them. So why are Native Americans opposed to mining? Well, in the 1950s, in the nuclear age there, where we were developing weapons, they mined a lot of uranium on the Navajo reservation, and these mines are still dirty. It's a legacy of bad things. So there have been health issues with the Navajo people, and the reservation costs of cleanup are estimated today to be $1.7 billion to clean up what's still there. Do we really need Grand Canyon uranium? It's very high grade. It's, you know, the percentage of uranium is really very, very high. But in perspective, the US only produces 1.1% of the world's uranium, and only approximately 0.2% of the United States uranium production is in the Grand Canyon area. So you multiply those out, and you get a very, very small number of the world's uranium that's produced in the Grand Canyon region. So you have that balance, you know, ecology versus nuclear energy. Uranium mining wasn't really going from the late 50s or 60s probably until very, very recently, the last 2 years. So why was it on hold? Well, it was uranium prices. Uranium prices peaked in 2008, and miners began to see that it might be lucrative to start mining uranium again. And it's come back up again. So on this scale, what you have is you have the uranium spot price on the y-axis, and this is in dollars per pound of uranium oxide. And then on the x-axis, what you have is you have the years, and you can see that this really price is a driver. In 2008, over 1,000 claims for uranium mines were claimed in the area of the Grand Canyon mostly because of this price spike. There's a long history of mining in the Grand Canyon, mostly for copper. What you're looking at is something called Grandview Mine. How many people have hiked in the Grand Canyon? Oh, quite a few of you. Any of you gone down the Grandview Trail? Aha, yeah. Right below Horseshoe Mesa is the Grandview Mine. It's closed off now, but when we were doing our work, we could actually go in. So that's my graduate student, Jim Fitzgerald. And you can see that a lot of the uranium was associated with water coming down fractures and cracks. You can see all the copper material coming down, and copper was a big thing that was mined for a while. Uranium was mined, and actually, 100 years ago, people thought it was good for you. They would wear uranium in little necklaces or bracelets as a health benefit. That really is not the case, but that was the thought. But it's also very beautiful. In Grandview Mine, this is one of the formations, or one of the things you only find in that mine. Nowhere else has it been found. And so it's fibrous turquoise. And it's really very, very beautiful. So if you want more information, a 10-minute film, if you Google "Too Precious to Mine," it'll talk about the economic issues. In northern Arizona, the mining is not an economic big benefit. It's recreation. It's fishing, hunting, hiking, boating. It talks about that. It talks about the Native American perspective as well. So in Horn Creek in the Grand Canyon below, one mining area, my graduate student and I found high uranium in something called Horn Creek. So Horn Creek is, let's see if I can get this to work. Well, yeah, don't worry about it. This is Horn Creek right here. And if you look, you'll see an added to orphan uranium mine. Oh,
It's that top button.
it's the top button. They just don't give out these PhDs. So that's Horn Creek there. Thank you very much, Brooke. Here's Horn Creek. That's the adit, and the mining operation was up on top here. It was started actually in about 1905 by a guy named Hogan, who was doing copper mining. And then for about 13 years, from the 1950s to 1969, they mined for uranium in this lost orphan mine. We were the first ones to really find high uranium over drinking water standards. The standard for drinking water is 30 micrograms per liter. And so all the way down into the Vishnu schist, all these springs and seeps are over the drinking water limit. This started the Park Service thinking. The mining site up at the top, which was closed, was a visitor attraction. And people would come and they'd look at the headworks, and it was really nice. But they thought, well, maybe the soil is contaminated. So they dragged a Geiger counter around, and it was hot, radioactively hot. So they closed the visitor attraction. They knocked down the headworks. They dug up the soil, and they carted it off. They put down geotextiles, and then they put a fence around this site. So if you go to the South Rim, this is about a mile from the South Rim Village. No, excuse me, about 2 miles from the South Rim Village on the West Rim Drive. The very first stop you stop at, that's where the mine is. And off to the side, you'll see a fenced area. So the question that I'm going to address today is, can mining pose a threat to water quantity and quality in the Grand Canyon? This is a current mine that's been operating now for about 2 years and 2 months. And it was called Canyon Mine, but they thought that had too close an association with a canyon. So now it's called Pinyon Plain Mine. And in this, you can see the evaporation pond here. You can see where ore is stored. You can see headworks over here. And it's really close to the Grand Canyon. This is an overhead shot. You can see a little snow on the ground here. It's about maybe just under 6,000 feet elevation. And if you zoom out, you can see the Grand Canyon over here, about 8.5 miles away. So the proximity is something that concerns a lot of people. By the way, I'll be talking later about Havasu Canyon. This is Havasu Canyon over here, also called Cataract Canyon. And you can see it goes all the way out here. And we'll talk about the direction of groundwater flow in a bit. So there's the Grand Canyon. There's a Canyon uranium mine. So what is breccia pipe mining? First of all, I'll talk about what is a breccia pipe. And something my students always ask me is, can you smoke it? And the answer is no. So, and how did uranium get in the pipe? So let's just talk a little bit about mining. For those of you who are mining people in the audience, note that I'm going to say some things that are a little critical of the mining view of the environmental safety. But I personally am all for responsible mining. I'm a big fan. And so take that into consideration. So here we have the Grand Canyon sequence here. And there's a lower aquifer, water-bearing strata that supplies most of the springs of the Grand Canyon. It's called the Redwall Mauve Aquifer. And then there's an upper aquifer that's in the Kaibab, Torweep, Coconino, and Supai, and that's called the Sea Aquifer, sometimes just for Coconino. That's the, what you can see here is you can see between the Hermit Shale and the Coconino, that mark is where waters come down and then come out. This is travertine right here, showing that water used to flow out of that contact. And this is another spring that comes out of that same place called Dripping Springs. So how do breccia pipes form? Well, down in the limestone, if you've ever hiked in a limestone cave, you know there's a big cavern. Over geologic time, the roof collapses. And as the roof collapses down, you get a chimney of broken rock. That's what breccia means, broken rock. And it's their little depression on the surface of the rim. Surface water likes to play connect the dots. And sometimes surface water flows down in these pathways. And water over geologic history moves up and down. Uranium likes to stay in water if there's a lot of oxygen. But when it goes to a low oxygen zone, like a reducing zone, it chemically precipitates into ore, into solid ore. So in the low oxygen areas, the reducing areas, it is deposited, and the chemical in there that does it is the sulfides in the gypsum and other things that are in the pipe itself. So that's a breccia pipe. Now, the mining, I want to give you the mining arguments for why this is safe. And so they have basically three reasons. The first is, oh, I went too fast. They used to say there's little or no water in the perched aquifer. They call it perched, the upper aquifer. I'll address that in a second. The second thing they say is the geologic dip or the tilt of the rock is away from the Grand Canyon, so the water should flow to the south-southwest. And the third is that the upper aquifer and any water that's in this upper little aquifer and the top, they're not connected because the rock between is pretty much impermeable. So I'd like to address that now. And so let's talk a little bit more about what happens. Let's talk first about no water in the upper aquifer. They did, in the 80s, they did some test drilling and there was water in the shallow boreholes, in the shallow exploratory boreholes. So in 1992, I argued before the Arizona Department of Environmental Quality that they had to be careful. And they said, no, this is just drip water. This is not going to be a problem. And so here are some of those holes, and they have a deep well that they call a monitoring well, but it's also a supply well at this particular Pinyon Plain mine. So they have a shaft, main shaft that went down 450 feet. And in 2016, they extended it to 1,400 feet and then 1,450 feet. And they hit a gusher. They hit so much water that their pond couldn't hold it. So they took water cannons and they shot water into the atmosphere to evaporate. This water was really high in uranium, but even higher in arsenic. And it's been so high in arsenic, now the mines want to, they had a limit that they were supposed to not go above. They've now are lobbying to extend that limit even higher So arsenic in higher concentrations can be shot into the atmosphere. So they're dewatering about 8 to 10 million gallons a year. So it's not only a water quantity concern, it's a water quantity concern in addition to water quality. So they're also putting a lot of oxygen down there. When you put shafts and vents and, you want miners to be able to breathe, you're adding oxygen. And remember, oxygen mobilizes uranium into the dissolved phase of water. So will the uranium get legs and start moving through groundwater? I must admit, I had fun with this one. So drying up of springs, if it's about 19 gallons per minute, that eventually comes out to about 10 million gallons a year. By the end of 2023, 66 million gallons had been pumped out. This is the upper aquifer that they said was just drip water. There wasn't much. So we're pretty much sure now that that first thing that the mines insisted really was the case was not the case. I talked about the contamination. On the y-axis is the concentration in micrograms per liter. And on the x-axis are different years. And you can see at this point right here, this 2016 where they extended the shaft, the uranium concentration, which is this sort of tan butterscotch color, immediately went up. But the arsenic concentration went up even more and is continuing to climb right now, water that's being pumped out of the main shaft. The limits for EPA drinking water maximum for uranium is 30 milligrams per liter, and it's 10 milligrams per liter for the arsenic. So we're way over limit. The biologists from the Arizona Department of Environmental Quality say it's safe because there's a fence around the property, but I don't know. I'm not a biologist. It seems to me like bird life could probably access this evaporation pond. They only have one single monitoring well, and most scientists from universities, academics, University of New Mexico, Lawrence Livermore Laboratory, and others, they think that this is inadequate. Nevin Kresik was the chair of the Karst Commission for the International Association of Hydrogeologists, and he wrote a book called Notable Springs of the Grand Canyon, in the United States, and one chapter was on the Grand Canyon. And he said, based on his professional judgment, the statement by the Arizona Department of Environmental Quality is nonsensical. And most people in geology know that you've heard of a 3-point problem, where you try and get the dip, you need 3 points to define a plane mathematically. It's the same with groundwater hydrology. In the simplest case, where everything's homogeneous and isotropic. So a lot of people think the single monitoring well is inadequate. For example, if the monitoring well is in one place and the groundwater is moving in a direction, and the mine is over here, it's up gradient. And even if it's in the correct place, down gradient from where the pollution might go, you've been in caves, there's all sorts of passageways. What if there's a passage that's contaminated, but other clean passages that mix with it? Then what you'll get is a dilution or a false negative. And so that's one of the concerns. I taught how to build a monitoring well for the EPA in 10 different cities around the US, a lecture series, and this is not how you do it. The other thing is, if you pump water out of a well, you can change the concentration as you do that. And so the uranium concentrations in the deep well, they have varied greatly. You can see some of the numbers there, 309 micrograms per liter, 16, and also the sulfate and the iron really has varied, and that is likely a function of the pumping rate. By the way, I like to throw in pretty slides of the Grand Canyon for those of you who have not been down. If you haven't noticed, it's something I like to do. So let's talk about the second thing the mine said. They said the dip or the tilt of the beds is to the south-southwest, away from the canyon. And that's true. The north rim of the Grand Canyon is about 1,000 feet higher. And you can see here that it dips away from the canyon. And so in a simple layer cake geology, you would expect that the water would move to the south-southwest. Now, one inkling, if it moves to the south-southwest, it's going to hit the canyon that the Havasupai live in, but let's leave that alone for a second. But does it really move to the south-southwest? Well, in 1996, they wanted to build a housing development, which never occurred in the Grand Canyon region. And they modeled the groundwater flow. And they said that south of the Grand Canyon, there was a fractured zone that they called the Markham Dam Fractured Zone. And in their model, this is it. And they modeled the groundwaters moving to the north, to the canyon, not to the south. The USGS in 2024 had this, and I'm sorry, the quality of this is not great, but you can see these blue arrows. That's the direction of groundwater flow. Let's put in Pinyon Plain Mine near Tusayan. And here's the Supai village here. So you can see that there's a concern that you might have contamination from the mine. Let's just draw that in. This is, again, Cataract Canyon. This is the watershed for that canyon, and the mine would be right about there. So there are also USGS work that says this is a USGS guy. These are all USGS reports. Groundwater in the upper aquifer, the Coconino, discharges to South Rim Springs, which are smaller in discharge, or percolate deeper through faults to the saturated, unsaturated Supai group and to the red wall. And so the shape of some of the drawdown, right now they're pumping water out of the mine to dewater it, and the shape of the cone of depression kind of shows that the water is moving to the northeast and not to the west in the upper aquifer. The last argument they make, the mines make, is that, and ADEQ, the Arizona Department of Environmental Quality, has signed off on this, that the upper aquifer and the lower aquifer are not connected. And first of all, let's talk about the Swiss cheese factor. They have over 17.5 miles of exploratory boreholes in this breccia pipe. That these are open conduits where groundwater can flow all the way down to the Redwall aquifer. So even if the rock was totally a barrier, they pierced that barrier. So let's draw those in. I couldn't draw 17.5 miles in this picture, but you get the idea. From the main shaft, they had a lot of exploratory boreholes to find out where the uranium was. And then when they do the mining, they're going to put drifts off to the side, horizontal drifts, and then they're going to do gravity. They need a way to get vehicles down there. And then they're going to open up these big cavities down there. So oxygen is going to be added, and there's going to be a lot of ability for groundwater to move. I'm going to skip that one. Another thing we're concerned about is other breccia pipes nearby. In 2015, the Arizona Geological Survey said, they asked the question, what if we decided to see if there were other breccia pipes in the neighborhood? So they took these two squares and they decided to look more intensively for other breccia pipes. And so those dark blue dots that you see are new breccia pipes that were not known before 2015. 10 times the number that were there before. And so nearby to Pinyon Plain Mine, by the way, I just shown, you- the red part is the new national monument. It's the ancestral footprints of the Grand Canyon national monument around the Grand Canyon. And a lot of those are in that. Pinyon Plain Mine is right about here. And whoop. So what if there's another breccia pipe nearby? When mining operations cease, if groundwater were to flow from the mining area into that other breccia pipe, it could go down to the main aquifer. We know of at least two breccia pipes that are right within a mile or two of the Pinyon Plain mine. So in other words, there's other pathways for contamination to move. So are the aquifers connected? The Arizona Department of Environmental Quality and Energy Fuels, which is the company that runs this, they say no, the two aquifers are not connected. Well, there were dye tracer tests that had been done. This is Ben Tobin, and we put the tracers up on the rim, and they went all the way down into the Redwall Mauve, all the way down. They've done this on the South Rim recently. They didn't put enough tracer in, but they have found recent chemicals, pharmaceuticals, and PFAS, per and polyfluorinated aliphatic compounds or substances in Monument Spring in the South Rim. So there's evidence that there's fast flow that the mines deny. Also, the one time they measured freons in the deep well at Pinyon Plain, they found it. Now, the first freons came from refrigerators in 1932, and in 1932 and a half, it started leaking into the atmosphere and coming down with rainfall. So if you find CFCs, the mines insist the water in the deep aquifer is 10,000 years old. Well, no, some of the water with CFCs is less than 100 years old. So the most common scenario you see in a lot of cave systems with hydrogeology is it's a mixture of old flow paths and short flow paths. And that's what most of the people who criticize the mine's view say. There was an expert panel put together by EPA. I really like this cartoon, by the way. I don't know if you can read the small print, but it says, "Thank God, a panel of experts." EPA panel, they concluded that there wasn't enough information to really determine whether those two were connected or not. So what I'm going to do is I'm going to make this simple with some graphics for you, graphics that I kind of like. Because they said it was layer cake, we decided to make the Bright Angel Food layer cake. Those of you who've hiked the Grand Canyon know the Bright Angel is a creek that runs down, but it's also a layer of shale in the Grand Canyon. So we call this BAFLAC, or the Energy Fuels Bright Angel Food layer cake. And so it's a nice layer cake of aquifers and geologic strata, some less permeable than the others. And so let's tilt it. We're going to dip it to the southwest, away from the Grand Canyon. And so the mines assume in their conceptual model that it assumes homogeneous isotropic layers, that those assumptions are sufficient to represent the geologic layers, and that homogeneous, they're all, they're similar, and it just flows toward the southwest, by the way, toward Havasu Canyon. And the second thing is that they say that there's an aquitard layer practically impermeable that won't allow contaminated groundwater to move downward from the mine works into the regional Redwall Mauve aquifer, which is a really important aquifer with a lot of big springs and a lot of ecosystems. And so I'll draw that in there. There's the barrier. So here's the mine's model. And I put a breccia pipe in the middle just for fun. So this is a simple, easy to follow conceptual model. And so let's make it a little bit more complicated. Let's throw in the aquifers. So we have an upper aquifer and a lower aquifer, which we've discussed already. And there are multiple lines of scientific evidence that these two are connected. And I'm going to take a quick trip to talk about some of those. First of all, USGS, I'm not sure I'm going to have time to go through all these in great depth, but they said because of some of the stable isotopes they looked at and some of the other parameters, tracers, that there's a connection between the upper and lower aquifer. Even in the environmental impact statement in 1986, they said that the water could continue to percolate downward to the Redwall Mauve aquifer from the upper aquifer. And lastly, that lower one there talks about a great flood. It was a 500-year flood that wiped out the road to the Grand Canyon in 1984. And it zoomed right by this Canyon uranium mine site down something called Red Horse Wash. It was a huge amount of water, over 2,000 cubic feet per second. And within 5 miles, it disappeared. And most likely, it went down. So there's evidence that water can go through. And then some academics, just last year, well, a little bit more than a year ago, University of New Mexico, natural and anthropogenic tracers show that recharge can travel 2 kilometers vertically and tens of kilometers laterally. I'm going to skip that last statement there. Again, because I don't have a lot of time, I'm going to go through these very, very quickly. These are multiple lines of evidence that the upper and lower aquifer are connected. These are called stiff diagrams, which are the major anions and cations. Major anions are negatively charged. They include chloride and sulfate. Major cations are positively charged. That's things like sodium and calcium. And you can map those very quickly. And these are the major anions, and they look sort of like this one. These are similar in concentration. And these are springs of the Grand Canyon that look similar to the mine. So the one in the middle is the mining major anions and cations. Trace elements. Concentrations on the y-axis, different trace elements. These are the rare earth elements. Back in the 90s, we looked at this and we saw that there was a possible connection. Not going to spend a lot of time, but in the questions and answers, if you want to talk more about these, I'd be happy to talk more about it. The one that's different, by the way, is not groundwater. That's sewage outfall from the South Rim. Uranium isotope disequilibrium versus tritium. Tritium ratio on the bottom scale, X scale, uranium 234, 238. Very often when you have a ratio of 1 called secular equilibrium, it's from a mining area. This one that I just circled is from Horn Creek below the Lost Orphan uranium mine. All right. They do have this data at Pinyon Plains, but they haven't released it. So that's one of the things we're urging them to do now. Fracture analysis. If you really want to see if water's flowing through fractures, you put in multiple boreholes and you do sort of like tomography, you know, like when you have an MRI, they shoot you in all directions and you can see what's inside you. Well, if you have more than one borehole, and they do, you can look and see if a fracture continues on, what its aperture size is, and whether you can even test it to see if there's flow in it. That has not been done. There are faults and folds in the area, which I'll address now, but the Vishnu fault goes right through the area. The mine is right about here, right there. Oop. I'll skip this one. This is just seismic stuff in the area. So let's go back. Here's our Baflac, our Bright Angel food cake. Let's put in some folds. This is called, we're going to fold it. That's the Grand View monoclines toward the Grand Canyon. So there's our hands folding the cake. The cataract syncline, a syncline is a downward moving thing. So let's punch it there. There's a whole bunch of faults and folds. Let's make little ones here with our fingers in the cake. Okay, so now our cake is looking a little bit different. And there's named faults and folds. And so we're dealing with folds here. Let's deal with faults. So let's take a carving knife and add some faults to this cake. You can tell I had a lot of fun with this. And so there's a lot of faults and many, many unnamed faults. in the Grand Canyon that could act as conduits for groundwater flow between the upper and lower aquifer. The cake's brittle, and so a lot of these smaller fractures can conduct water. So let's put in the brittle part. There are over 1,000 breccia pipes in the Grand Canyon region. So let's get an ice pick and let's put in 1,300 breccia pipes. And then there's, remember, 17.5 miles of exploratory boreholes and other cavities being opened up, which are conduits that can allow water to flow further and faster. And then there's Tusayan actually has some deep wells. It's a town 10 miles south of the Grand Canyon. And so they're pumping water and that can change groundwater direction. And then the dewatering, let's not forget the dewatering, which is 8 to 10 million gallons a year that's being pumped out of the mine itself. Finally, let's throw in seismic activity. Well, not finally. I have one more after this, but I had a lot of fun with this one. Maybe too much fun. Okay, you get the idea. That could open up fractures and faults. And last is subsidence. Because you open up cavities in a mine, those cavities can collapse afterwards. And this will open up conduits and ways that things can flow. And so after closure, you might have other pathways that water could go. So let's subside this whole thing. And you say ridiculous. Well, let's go back to Orphan Uranium Mine in Horn Creek. This is subsidence. This hole is getting bigger and bigger every year as the old mine in Horn Creek collapses in itself. If you look closely, you can see some side drifts, horizontal drifts going out, a little bit of blue in there for copper-related things, but that's one of the concerns is post-closure. So let's take the original BAFLAC model and now the complicated real model. And you can see that this old model really may not hold water literally. So from here, you might go there. If you want to read more of this in a layman's terms, we wrote something, myself and some professors from the University of New Mexico, Laura Crossi and Carl Kolstrom, grad student of mine, Susan Lederer, and Carla Tulowski, who is actually a member of the Havasu tribe, wrote this for the Grand Canyon River Guides. It's about 2 or 3 pages, and it goes through some of these arguments. And I can get you that reference if you want. I'm not going to talk about soil contamination other than some soil is contaminated outside the mine. I will talk about atmospheric pollution. I like this sign. Okay. So one of my graduate students worked for a group that supports the Department of Energy. If there's a nuclear disaster, these guys would fly over and measure radiation. You could do it fixed wing, you could do it with helicopters, and now you can do it with drones as well. They put out this report. I didn't twist arms, but I asked, could you do a training mission over this mine to see if radiation is coming up in the atmosphere? And they said, yes, we could do a training mission. So they did training missions before the mine started operating and after, and I want to show you a comparison of that. And Dan Haber got his master's and just recently got his PhD at UNLV on this, and he's one of the team that I want to make sure I give attribution to. So you have a silver iodide collector that flies over, and there were 2 flights, one in 2019 and one in 2024. And you do a pattern back and forth, sort of like if you were searching for a victim under an avalanche or something like that, and over the mine, and you measured the radiation, gamma radiation coming off. Now, this is before mining in 2019. And I want to bring your attention to the numbers here because the picture doesn't really show what really happens. Notice it goes from less than 3.25 microrems per hour to about 7.25. Now I'm going to show you afterwards. Now the picture looks smaller, but when we blow up the exposure, now it goes up to 500 millirems. All right. So you can see that there's radiation going into the atmosphere there. And so that's another concern, that and soil contamination outside the mine that might affect wildlife and things of that sort. And a lot of the contamination was centered around where the ore piles were. Okay, in this last 10 minutes, I'm going to have some fun, talk about what it's like sampling and hiking in the Grand Canyon, and even river running. And I told you a little bit about winter and summer being interesting times to be doing sampling. There are also interesting creatures like rattlesnakes. It is true that people can fly. If you're about to step on a rattlesnake, you find yourself several meters down the trail, not knowing how you got there. We also did surveys of biota. You can see in the lower right, that's me doing some measurements where invasive species are happening along the river. The middle picture is one of my graduate students just before he jumped. Just kidding. But it's a beautiful place to work. If you're down the river and it starts to rain, suddenly you get an effect that sediment-filled waterfalls appear everywhere. Greg mentioned 1983. This is Crystal Rapid in 1983. It was rather sporting. I've got all sorts of stories of our flipped boat and people going long distances, which I was able to tell them some of that. This is me rowing the boat in Upset Rapid. Sorry it's so loud.
There they go.
This is Horn Creek Rapid. It's got the biggest drop over the shortest distance. And he's rowing left. He goes under some horns because there's some big waves down on the right. This is a winter trip. And I went a little bit further right into this big stuff on the right. In winter, the sun doesn't hit the bottom of the canyon except in a couple of places. So you're in the refrigerator for a long while. This is a small one. I'm in a boat off to the left. A little yellow boat there is me. I'm not rowing this one. This is called Tiger Wash Rapid. Terrible tiger. And you can see even with the small hydraulics, it does an interesting thing to this boat. Crystal Rapid left-hand run. I'm rowing this boat, 2 passengers. I made a pretty good run, except at the very end, there's a little bump. There's a big hole to the right. I'm avoiding. He'll show you in a second what I'm trying to avoid.
All right.
That's what I'm trying to avoid. Get away from the rock. I'm rolling back. And there's a little bump. Yeah, every trip through is a real experience. So I'd like to close with, I've gone through some things really quickly. If you have questions on some of the things I raced through, I'd be happy to discuss it. But advice for you, especially you students that you didn't ask for, be brave enough to suck at something. And then always kind of question so this is my last slide. I could go through every single thing I've talked about, the layer cake and the arguments for and against, but just know that there's serious scientific concern about uranium mining. And some of the assumptions may not be true. And if they're not true, we might not know for years, but it's a legacy that you really can't take it back once it occurs. And so a lot of you know about a principle where you are very conservative when you're not sure what's going to happen, especially with a precious resource like the Grand Canyon and its springs. And so I thank you for your attention. This is me going through Crystal Rapid in 1983. If you survive being young and foolish, you get to be old and foolish. So thank you again for your attention. Really appreciate it.
Thank you, Dave. And we have a gift for you from the geology department. This is a book from a former professor in our department.
Oh, thank you.
Up to you. So yeah, thanks.
Oh, that's beautiful. Thank you. Thank you. You have time for questions.
Yeah, so we have a couple minutes for questions. Everybody, and we'll also be out here in the lobby.
You can assign the textbooks for the students that.
I'd be happy to sign them. Yeah. Yeah. They'll be worth less. I joke that, like I give them away at some conferences and first prize is 1 book, second prize is 2 books, third prize is 3. We got some questions here. Yeah, here first.
Any other mines on the north side of the canyon? And how many are there on the south side besides just in?
A good question. I'm going to repeat it so people can hear it who online. Are there any other mines on the north side of the canyon? Under the Obama administration, there was a moratorium put in by the Secretary of the Interior on any new mines, but about 5 mines were grandfathered in. And now this mine is actually in the new National Monument, and there's no mines allowed in the new National Monument. But the old ones that were grandfathered in on the North Rim, they're thinking of reopening one. One of them completely flooded. That was called Pine Nut Mine. There's Hack Mine and Arizona 1 and 2 on the North Rim. And off to the side near the Wallapai Reservation, there's the old Rittenhauer Mine, which is inactive. So right now, all the other mines are inactive, but they're thinking of opening up one of the Hack mines right now. Yeah.
Okay, yeah, so once a mine has been given permission to mine and to do stuff, is there a way to review and then take away the permission to do it? So they made assumptions, those assumptions are seemingly, being proven to be false. Is there a way to call that into review?
Yes and no. Myself and a couple of other academics have been in touch with the governor's office and the state attorney general for Arizona. And particularly it came to a head when some of the uranium ore was being hauled across the Navajo reservation that they said was illegal, and they wanted to arrest them. However, the roads are federal roads, and so that didn't work out. But there were negotiations that went on for several months, and now they're reopening studies to see if there is a connection or not. And so if the results of that, it's a little late because, mining's been going on for 2 years, but maybe there can be some ways to plug up some of the holes to do better monitoring in the red wall mauve, in the deep aquifer. If you do better monitoring and you do find it leaking, what you might be able to do is extract water from the deep aquifer, sort of like an interceptor sort of thing to keep it from getting to the springs. Again, there's a water quantity issue that is always rather salient. So the answer is maybe. Yeah, other questions? Here.
When they were doing the tracer tests, were they injecting that water at the mine and collecting it at the springs?
No, that would have been optimal. They were, first of all, most of the tracer tests started on the north rim, this on the south. And so the north rim, they saw it go all the way down. And some of the tracers were really strange. They were close to the rim of the Grand Canyon, and instead of going to the springs close, they went 10 miles out in either direction and came to other springs. And then they went further away and did another test, and it went straight instead of going sideways. Yeah, yes, a large area. And but it did go from the rim 1,000 feet higher than the south rim all the way down to the red wall mauve. The shortest times were about maybe 2 months. The longest time were about 2 years. Yeah, yeah. Exactly. Those are the ones they started with. You saw the red color and the green color. The ones on the south rim, they injected into the sewage outfall on the Bright Angel Fault. And they don't think they put enough in because they got little trace amounts, but not enough that they could really report. But at the same time, when they were collecting, that's where over Monument Spring, which is actually a couple of miles to the west, they found the pharmaceuticals. And this is not near the campground. This is up where the spring comes out of the rock. They found PFAS as well. And so there's some indication that there's short pathways to these springs, even if it's mixed with old water.
The transit time, get some kind of a ballpark estimate on transmissivity or connectivity?
It's tough because it's a mixture of fast flow and slow flow. They said 10,000 years, and some of their dating was carbon dating. Anybody who knows about carbon-14 dating in groundwater knows that you know about it with bones. When you're looking at an anthropological site and there's bones, you're breathing in air. It's got some carbon in it, carbon dioxide. It's got a little bit of carbon-14 in it. It gets into your bones. You die, boom. Now the clock's on. The carbon-14 starts to go away. It starts to have half-lives and it goes away. And you can tell how old it is. The problem with groundwater is the same thing happens, but in the rock, you have carbonate rock with carbon in it that's been there for a long time. It has no carbon-14. It's dead. And so if the water coming down mixes with a country rock, then you get a false old age because it mixes and gets some of this dead carbon where carbon-14 used to be. What? What?
There's a slide where you were showing tritium.
Yeah, we do. We looked at tritium and we found tritium as well. Yeah, and tritium is mostly from bomb pulse stuff. Now we did those tests. That's from the 1990s. Now tritium is almost gone. And so when you look at tritium, which is heavy hydrogen and is radioactive, now you kind of look at it with helium as well, helium-3. You do a comparison and you can get a groundwater age that's from tritium, even though a lot of the tritium's gone from the bomb pulse of atmospheric testing in the 60s and 70s.
Radioactive iodine or something and then try to pump it out of their deep well.
No, but they insist that they collect all the water in their deep shaft. And the truth is, with its Swiss cheese, there's a lot of opportunity for water to bypass their deep shaft. And that's something that the mines have not acknowledged. Some of the boreholes actually penetrate the deep aquifer. There was a question over here. Yeah.
Kind of sociology, I wonder, possible and successful democracy though, the mines. Everybody doesn't want to live by a mine, and almost every mine has complicated geology. And so I wonder if it just becomes, we're kind of offloaded to less successful democracies, or at least big, or otherwise, I don't know how you get it done in a successful democracy. Well, the complications of mine.
You bring up an interesting point, and I'm going to address that question with retropite mining. See, are there other mines is the question. And I'm sorry I didn't repeat all the questions for the people online. But for retropite mining, they found out that 90 to 95% don't have any ore in them. And where there has been ore, there is this sulfide reductant in the pipe. The sulfides, you know, are low oxygen grabbers. And so yeah, that's the scientific term. They just don't give out these PhDs, as I said. But what happens then, they've just recently done sulfur isotope analysis. And they used to think that the sulfur came from below with hydrothermal water, but it's not, the isotopes are not showing that. What the isotopes are showing is these are gypsum beds higher up. And so the sulfur, to make the sulfate reductant, may have come from above instead of from below. So it's a very interesting thing. And only about 10 to 5% of these retropipes are mineralized.
Very cool. End it right there. Be out here in the lobby if you ever need questions. Thank you. If we have a geology field trip to the Grand Canyon in a couple weeks.
It's a geology club.
Geology club. Yeah.
Do you need somebody to tag along?
Yeah.
Let's talk. When is it? If I don't have anything else, then you want me.
Great job.
Thank you.
Not bad for high quality.
Yeah,
You know, the others proved very well. No, you really did. It's great.
Yes.
Can you stop mining like right now? Do you think a lot would change, like, would it actually have that much of an effect on stopping what has already started? Do you think like uranium would, or other contaminants, wouldn't it would slow down the process?
well, if they,
So upload your notes as they are. Go on and. Such okay. You're it. I was like so sad. Glad you're here. Well, thanks for coming. Go get some treats. They got so good to see you, and I'll see you on. Are you Monday? Are you Colorado? Yeah, Utah. Oh, I'll see you on Tuesday. All right. Bye, Hazel. And get up. Last year. I'm sorry, I almost did it. But then I chickened out, so.
Sorry.
Good time.
Yeah. So I did.
Have fun, enjoy it, for coming. Yeah. You don't remember.
And I teach the food.
I knew I would.
Yes. So far. That's the better half.
No, in Oman, dude, we're like, I don't know, this sounds like a fake Canadian girlfriend. I don't really believe it, but this one, good to see you real. We've been engaged for like a month now, right? That's all.
I never know.
Grand Canyon with us too?
Class. Class, I can't.
Nice to get paid.
It's nice, that paycheck really.
Especially when you gotta pay for a wedding.
It's a natural system,
For now.
but we usually.
Geology.
You said basically,
I'm a lot.
I'm getting email for something. Okay, then I need to that I can. If it's no. I just think a paragraph. No, I don't give you, I can't do it every year. Yeah, I'm like, it's usually white fonts is lost. Hiring sign, 90, but I've seen. Oh, yes, yes.
Saturday.
You'll see. But.
Really good that this tomorrow way. Nice, it's like, oh, it's here. It's right there.
It's right there. Literally took 6 days. Oh, yeah.
They were ready for this. They've been open for less. I can tell you who. Oh, like there's the 11 ticket clients.
The link to upload will be at home.
excited about it.
Flying around.
How you doing? Good to see you again. A little bit.
It was so loud. I just came in and I'm like, I'm sorry.
Val,
He's also got
he runs, he's actually gonna be putting on the field trip. How are you?
One of the Bahamas with us. This is.
like before, and it was.
Randy, and I'm like,
Never been, yeah.
Well, showed up.
I mean, we did everything.
Good job. Part of it, presentations by Josh.
For patrol.
Great presentations.
Yeah, they were.
You guys do.
Would say this one.
Oh, yeah, it's gonna be a learning suite. Sort of expect, sure, we can give him. Well, I think you have to be a registered student, if ever I could just add you to it. Let me check to.
Thanks.
Wait.
I'm like,
Box or something.
oh, you're,
I can take a learning.
upload your notes. I don't care.
You got a lot worse presentations. I should get back with you in the next, hopefully tomorrow.
Say, oh, you turned it in, you turned it in.
Seriously, second degree pizza. I just walked in the house Monday night. Dee Dee and Aaron had made pizza.
Check out.
I didn't know this, but it had just come out of the oven, like as I was walking in the door. 425 degrees. They put a piece on a plate.